Okay, so if we look at this set for example 1, all right, it says use a rectangle below to answer the following questions. So for these ones, just for time purposes, guys, I'm just going to find the variables, okay? I'm not going to find like BD, all right? I'm just going to find the variables, okay? So if you look at the first one, it says I'm given BD is 8y minus 4, and I'm given AC is 7y plus 3. And it says to find BD, okay? So if you look at, with what we know about a rectangle, we know about the diagonals being congruent. So all I'm going to do is just set 8y minus 4 equal to 7y plus 3. So then solving that, I get y is equal to 7. All right, let's try the next one. So the next one says BC is 24 and AD is 5y minus 1. So we're looking at BC and AD, and because it's a parallelogram, all right, we know the opposite sides are congruent, which means that I'm going to do 5y minus 1 equals 24, which means 5y is equal to 25, which means that y is equal to 5. All right, now our last one, all right, might be a little, so I'm given BAE, so this angle BAE right here, all right, is 3z plus 10. And then I'm given that CAD, so this angle right here, is 2z plus 5. So if I remember what's going on with rectangles, we know that all the angles in a rectangle are right angles. So what I'm going to do is it's just splitting that right angle into two different angles. And so I'm going to add those together and set them equal to 90. So I'm going to do 3z plus 10 plus 2z plus 5 equals 90. All right, solving, I'm going to get 5z plus 15 is equal to 90. I'm going to get 5z is equal to 75. All right, and then dividing that out. So 75 divided by 5 is 15. Okay, so that's what's going on with rectangles. Okay, now if you look at example 3 now, it says find all the missing angles if angle 6 is 35 degrees. All right, and it's telling us that it's a rectangle. So what I'm going to do is I'm going to put in 35 degrees here. And there are a couple things that I can fill in right away. All right, so I know that this angle T has to be a right angle. So what I'm going to do is I'm going to do 90 minus 35, and I'm going to get that angle 7 is 55 degrees. Okay, now I'm also going to use my, the fact that it's a parallelogram, these are parallel, all right, and I'm going to use my alternate interior angles, which means that angle 3 is also 35 degrees, and angle 4 is 55 degrees. So that's very helpful, but as you can see, that kind of stops us, all right? So here's what we need to recognize. So what we need to recognize is that all of these segments right here are congruent, and you're probably like, well, why is that helpful? Well, the reason why it's helpful is if we now take a look, all right, at this triangle, what type of triangle is it? Well, it's isosceles, right? Because I have that my legs, all right, whoopsie, all right, my legs here are congruent. So what does that mean? Well, it means that the base angles are congruent, which means that angle 6 has to be congruent to angle 5. So now I know that angle 5 is 35 degrees. And so then to find angle 8, I'm going to add 35 and 35 together to get 70, subtract that from 180, which means that 8 is 110 degrees. Now, that can now push me over to angle 9, all right, because angle 9 now has to be 70 degrees because it's supplementary to the 110. And if I look at this triangle right here, all right, it is also isosceles, all right, which means that angle 1 and angle 7 have to be congruent. So angle 1 is 55, which means that angle 2, because this is a right angle right here, also has to be 35. And that's all the angles in there, all right? So again, when we're talking about these rectangles, it creates isosceles triangles, all right, which means that the base angles are congruent. Okay. All right. We'll do one more question, all right, before we pause. So on this one, it says determine if PQRS is a rectangle, rhombus, or a square. So what we're going to do, all right, I'm going to draw this as, I'm going to draw it as a parallelogram. Okay. And I'm going to label, all right, what I got. All right. So I'm going to have PQRS. And just make sure whenever you're labeling, it doesn't matter where you start as long as you go in a clockwise fashion. Okay. So it says to determine if PQRS is a rectangle, a rhombus, or a square, all right? And there's like multiple ways of doing this, okay? But if you were going to look at the actual sides, like PQ, QR, RS, and PS, all right, what we would have to do, all right, is we're going to have to use the slope formula and the distance formula, okay? And if you would concentrate on the sides, all right, you would have to do the slope formula 4 times, all right? You'd have to do the distance formula 4 times to see if the sides were perpendicular and then to see if the sides were congruent. I think that's a lot though, okay? So what we're gonna do is we're actually gonna focus on the diagonals, because if, all right, we could find that, so again, we're gonna focus on the diagonals, and we're gonna use the distance formula, all right, to see if they are congruent. And we are going to use the slope formula to see if they're perpendicular, okay? If they're congruent, we know that it's a rectangle. If we know that if they're perpendicular, then we know that it's a rhombus. And if it's both congruent and perpendicular, we know that it's a square, okay? So again, we're going to figure out what's going on with the diagonals. So the diagonals are QS and PR, all right? So I'm going to do QS, and I'm going to do PR. And I'm going to start with my slope formula, okay? So for QS, I'm just going to write those down. So -2, 4, and S is -2, 2, okay? And I'm going to find the slope. So I'm going to do -2 minus 4 all over -2 plus 2, which gives me -6 over 0, which means my slope is undefined. And so now I'm going to find the length or the slope of PR. So I have 1, 1, and then -5, 1. And so again, I'm going to find the slope. So I'm going to do 1 minus 1 all over -5 minus 1, which gives me 0 over -6, which gives me a 0. So if I look at the slopes of these lines right here, okay, I'm going to notice that they're perpendicular. All right, so I notice that those are perpendicular, which means that my figure is either going to be a rhombus or it's going to be a square, right? So what I have to do now is I now have to find the distance of those same diagonals, because if they're congruent, then it's going to be a square, but if they're not congruent, then it's going to be a rhombus, okay? So now I'm going to find the distance of QS. So I'm going to do -2 plus 2 squared plus 4 plus 2 squared. And I'm going to get 0 plus 6 squared, which gives me the square root of 36, which equals 6. And so then now I'm going to find the distance of PR. And for PR, I'm going to do 1 plus 5 squared plus 1 minus 1 squared, which gives me 6 squared plus 0, which gives me the square root of 36, which gives me 6. So as you can see, my diagonals are also congruent. So because they're perpendicular and they're congruent, I know that this figure is a square. All right, I'm going to pause there, all right, and come back with